questions from the audience here. Yeah.
Yeah, this is to Borna. Nice to see you guys. This is John Louis from Nevada. And I wanted to ask Ricardo about the sensitivity of validation to the velocity model. And Ricardo, do you have an impression about whether there's higher sensitivity at shallow depths or deeper depths? And if you do, what depth would that be? And also, do you have an impression about whether there's higher sensitivity to higher degrees of lateral velocity heterogeneity?
Okay, yeah, both answers are yes. And then the upper 500 meters to 1 kilometer matter a lot. And it also matters a lot because it's where we have for what the waves, how the waves behave at that level. Then the resolution that we have for the frequencies that we wanted to represent well are not very good. Okay, so down deep at tens of kilometers, right? Then you have bulk representations, and that's to be expected. And then the motion down there is kind of average over the larger distances, right? But then so you will like, in an ideal world, to have a very much finer view or representation of that upper 500 meters, 200 meters, because they influence a lot how good your validation is when you go over the 1 hertz kind of imaginary boundary in terms of simulation. So you get very good validation results under 1 hertz. When you go above 1 hertz, you start hitting that level where the details of the shallow deposits matter a lot more. And then in terms of the directions of the spatial resolution and so on, it's kind of the same answer. It just applied to that to that perspective.
I'll submit that the sensitivity to shallow velocity makes it conceivable to measure.
But my sense is that if you go into that part of the question, then Brendan will be much better to answer than myself.
Yeah, I think it's a great comment that, unlike without trying to make it seem easy, clearly improving our velocity models is drastically easier than improving our kinematic rupture generators and our dynamic rupture models, right? And particularly that's true from a perspective that the closer you are to the surface, the easier it is to measure. At the same time, as Ricardo was kind of alluding to, the closer you are to the surface, the finer the spatial scale is that you need to represent. So, clearly at large depths of 2 to 5 kilometers, there is small scale variability as well, but because of the nature of the wave propagation, that small scale variability is probably not as important as it is. Well, it's definitely not as important as it is for that same spatial variability in the near surface, just because of the frequencies that the near surface gives rise to. So yes, it's easier to measure the closer you are to the surface, but actually we also need much finer resolution in that measurement near the surface as well. So arguably that actually makes it harder to do a good job getting near surface characterization to the wavelengths that you care about.
Now, the only thing that I will add to both of our answers is that it pays off better than other things. Okay, so for instance, when Po Chen and Tom Jordan and so on did large inversions for the LA area, they were working at 0.2, 0.3 hertz. They were doing inversions for very low frequency, but the impact of the improvements that they developed for the velocity models could be felt at the higher frequencies for validation purposes. Okay, so any small improvement to the velocity model pays off significantly, even at frequencies higher than the ones the improvements were intended for.
Already answered, but Ricardo, if you can kindly, if you don't mind, share the answer with everyone so that everyone is aware. I can go ahead and read the question if you want, or you can just read it and then provide an answer to everyone.
Okay, so you mean the ones that were in the chat, right? Okay, so there was a question about availability of these kinds of models for Mexico City, and the answer I gave in the chat to GE is that yes, and I will mention two particular names of people who have developed models for Mexico City. One is Victor Cruz Atienza in the Institute of Geophysics at UNAM, and the other one is Leonardo Ramirez Guzman at the Institute of Engineering, also at UNAM. And then the second part of his questions, or her question, sorry, I don't know GE, is that whether these models were good in order to visualize and understand a specific, very localized basin or site effects. And then the answer is also yes. And then there are a good number of publications that will show you how in the simulations you can beautifully observe waveguide effects, basin effects, localized basin effects. In the region I know better is for the LA greater area. You could beautifully see San Bernardino Basin, the LA Basin, the Ventura Channel as it goes near the shore, and that gives you a very good idea. And in the case of Mexico City, I remember one of the simulations either done by Victor or by Leonardo, how you could see in the lake area in the southwestern part of the Mexico City basin, near Cerro de la Estrella, how you could see the waves channeling through that part of Xochimilco, where the amplification is the greatest. And in some places where these simulations have been done, there is, and I think Chiara or Roberto Paolucci can mention this in terms of the Turkey earthquake, and then there are other simulations for Japan that you can very well correlate either scenario or past moderate earthquake results of simulations with more recent damaging earthquakes. And I think Brendan could say the same for the New Zealand recent earthquakes in the last decade.
Question? I can ask a question then. I have a question for Chiara. So I know you have done a lot of work in terms of simulations of historical events all over the world, and accompanied with simulations and validation. So I would like to know your thoughts about the possibility of extending the simulation approaches and the also validation approaches you're utilizing to not historical events in terms of like source models. So what's your view on this? And Thanks a lot for this.
You can answer it from here.
Thanks a lot for the nice question. I would like also to add a comment on the previous question about the Mexico City, just also to bring our view on that. I wasn't directly involved in those simulations, but also with SPEED recently. We made an exercise of the numerical simulation of the Mexico basin. In that case, given the complexity of the Mexico basin, the focus was on the modeling of the basin with very, very low shear wave velocity, down, I think, in the simulated model, I think down to 60 meters per second. So the model, I think, is the most, the speed model for Mexico City is the most demanding from a computational point of view. But in that case, the source was just a point source. So it was a real event, historical simulation for historical, where historical is a way to say real event. So the source was a point source, so the attention was in the basin. And yes, to answer to previous questions, it was possible also for such a small event to capture and to catch some important feature of seismic wave propagation within the basin. So the propagation of surface waves within the basin, the focusing on the wave. And there are many other cases that we addressed with reference to the Italian context, where it was possible to model, I would say, in an effective way, the most important feature of seismic wave propagation that are closely related to the presence of complex basins, so complex topography, not only based in complex geological and morphological features, so not only geological strong, irregular geological features, but also in combination with the irregularity of the morphology, so the topography features. Coming back to the Floriana questions, yes, you are right in the overview that I gave before with the different case studies. We made a different simulation of real events. So making simulation of real events, the first step for calibration and for validation is to the comparison with the available recordings. However, we have explored also the possibility, and also Roberto made a very nice overview on that, of scenario earthquakes, of simulating scenario earthquakes, checking, validating those scenario earthquakes, and using those simulations within seismic hazard and risk frameworks. And the Istanbul case study that was presented by Roberto before is one of the most recent case study where different realization of rapture scenarios for Istanbul from the Marmara Sea segment of the faults, of the North Anatolian fault, were used directly in the probabilistic seismic hazard assessment. And I think that this point will be also addressed by Marco Stupazzini tomorrow in his presentation. Recently, also the Thessaloniki case study was considered to generate different scenario earthquakes, and there the idea, the work is ongoing, and then the idea was to use all these scenarios up to the generation of damage scenarios for the building stock in the Thessaloniki area. So as Brandon discussed very effectively before, of course the validation perspective changes when passing from historical real events to scenario earthquakes, and in particular going to the scenario earthquakes, multiple realization for a single fault or multiple faults. In that case, a special focus should be on the systematic evaluation, also on the different component of variability, so in the treatment of uncertainty and so on. All these points were very nicely addressed by Brandon before.
Thank you. So I want to please join me in thanking all the speakers for the nice, very good presentations and discussions.